Welcome back to Kamal Kunj Home Academy. Encounter with the art and science of ceramics. In this session, we will discuss about the manufacturing process of burnt or unburnt magnesite refractory bricks. And the first step is the selection of raw materials for making magnesite refractory bricks. Step 1. Selection of raw materials. For magnesite bricks. Now the various raw materials are: number 1, dead burnt magnesite. In short, it is written DBM, dead burnt magnesite. Seawater magnesia. Short, it is written as PPM, premium periclase magnesia. Premium periclase magnesia. And third is fused magnesia. Now magnesite, about 2/3 of magnesite reserves are found in China. Next is Turkey, and third is North Korea. Now, for making dead burnt magnesite, raw magnesite is used. Raw magnesite it contains MgO minimum 45%, and CaO maximum 0.75%. L23 maximum 0.5%. Silica maximum 2%, and iron oxide Fe2O3 maximum 0.5%. So for making good quality magnesite bricks, MgO should contain minimum 45%, lime maximum 0.75%, alumina and iron maximum 0.5%, and silica 2%. So these are the impurities present in magnesite: lime, alumina, silica and iron oxide Fe2O3. These impurities should be as minimum as possible. Now in magnesite bricks, this ratio, lime silica ratio, CaO to SiO2, plays an important role. Now this ratio controls the property of magnesite bricks. Now the effect of this ratio we will discuss later on because it will take time. Normally it should be more than or equal to 2.5% for good quality bricks. So we will discuss about this ratio later on. Now date burning is done. Date burning of raw magnesite is carried out at 1700 to 1800 degrees Celsius in rotary kiln or shaft kiln. Now seawater magnesia contains 97 to 98% MgO. Impurities are very less, but it also contains B2O3, which is very harmful. The chemical analysis of different types of raw magnesite are shown here. Impurities present in natural magnesite are CaO, silica, SiO2, Al2O3 and Fe2O3. These impurities should be as minimum as possible. And seawater magnesia B2O3 is generally not present in natural magnesite. B2O3 boric oxide plus boron oxide should not be more than 0.02%. Generally it is found in seawater magnesia. But it is very harmful. The chemical composition of seawater magnesia and fused magnesia are shown here in the table. For the production of burnt or unburnt magnesite bricks, generally dead burnt magnesia is used, or combination of these raw materials can also be used depending on the requirement. The next step is processing of raw materials. Step 2, processing of raw materials. Raw materials, that is crushing, grinding and screening. Screening into different fractions. So crushing, grinding, this processing is done crushing and grinding are done in jaw crusher, then roll crusher, then hammer mill, now the lumps of dead burnt magnesite or seawater magnesia are crushed using jaw crusher, roll crusher and hammer mill, and a part of DBM grains, dead burnt magnesite grains, is charged into ball mill. Ball mill for making magnesite fines. Producing fine powder. Now, after crushing and grinding, a screening is done into different fractions. Into different size fractions. Such as 3 to 5 mm fraction, 1 to 3 mm, fraction, and 0 to 1 mm fractions. Now, after screening, these fractions are stored in overhead silos. A part of magnesia grains are charged into ball mill for making ball mill fines. So all these fractions, magnesite fractions, grains are stored in overhead silos. From here, these are taken for making the batch composition. Now, next step is grading. Step 3, grading. What is grading? The proportion of different size fractions for making the bricks. The proportion of different size fractions of different size fractions in the batch composition. Generally, grading is like this: 3 to 5 mm, around 20%, 1 to 3 mm, 25%, and 0 to 1 mm, 25%, and fines 30%. Total it is 100%. So this is DBM, dead burnt magnesite, 3 to 5 mm, dead burnt magnesite fraction 1 to 3 mm, dead burnt magnesite 0 to 1 mm fraction and dead burnt ball mill fines. This is ball mill fines. Now the figure shows different steps in the manufacture of burnt or unburnt magnesite refractory bricks. Now batch is made according to these gradings. Different fractions are taken in batch making car from the overhead silos. Next step is batch making. Batch preparation. For the batch preparation. Different size fractions according to the set composition are taken into batch making car from the overhead silos. Different fractions are taken into overheads from the silos. Then it is charged into the mixer. So next step is mixing. Now, what should the order of mixing? Order of mixing: coarse fractions taken first. That is 3 to 5, 1 to 3 and 0, 1. Taken first, then mixed for initially dry mix for 2 to 3 minutes. Then binder is charged. Now, what is the binder? Binder for burnt magnesite bricks making. It is either sulfide pulp waste liquid its density is around 1.2 to 1.22 gram per cc. Used up to 3 to 4%. To 2%. Now order of mixing. Next is mixing. initially coarse fractions are dry mix for 2 to 3 minutes, then 3 to 4% binder is used. Now, besides sulfite lye, another binder is for making burnt refractory, that is brine. Brine is aqueous solution of magnesium chloride. Its density is maintained at 1.2 to 1.3 gram per cc. These two binders are used for making, either of these two, making burnt magnesite bricks. And for unburnt bricks, magnesium sulfate solution is used. That is Epsom salt. Epsom salt is used. Water is 100, suppose water is 100 parts, 100 part, then Epsom salt is 30 to 60 parts. This is the aqueous solution of magnesium sulfate, is used for as chemical binder. This is chemical binder for chemically bonded magnesite bricks. Then binder is used and mixed for 10 minutes. Then BBN fines are added. Ball mill fines is added. and mixed for further 10 to 15 minutes. And mixed further for 10 to 15 minutes. Now, as shown in the flow diagram, after proper mixing, the mix is charged into the press hopper. The next step is pressing. After proper mixing, mix is charged into press hopper, from where calculated amount of mix is taken into the mold cavity for pressing. Hopper, from where calculated amount of mix is taken into mold cavity for pressing. Pressing is done at a pressure of 1 to 2 ton per centimeter square, depending on the size of the bricks. After pressing, as shown in the flow diagram, bricks are transferred to the dryer for drying. So next step is drying. Now at the time of pressing, only grain densities of the pressed bricks are checked for high quality measurement. After pressing, at random samples are checked for grain BD. After pressing, random samples are checked for green beading. Green beading gain bulk density. It should be around, density should be 2.9 to 3.0 gram per cubic centimeter. After pressing, green bricks are transferred to the dryer. Put in dryer for drying. Drying at 100 to 120 degree, 100 to 150 degrees Celsius. Yes. Next step is firing. Firing is done either in chamber kiln or tunnel kiln. At temperature of 1550 degree to 1650 degree Celsius. Firing cycles takes 2 to 3 days. Drying is also done in tunnel kiln or chamber type dryer. Tunnel dryer or chamber dryer. After firing, bricks are sorted for any defects. After firing, bricks are transferred to the brickyard. After that, sorting and inspection is done. Sorting and inspection of random samples. Is carried out or done. And then after thorough inspection, bricks are supplied to the customer. Now we will stop here, continue further in the next session. Till then, goodbye and thanks for watching.